So suppose the manufacturer of a gas clothes dryer has found that the unit price is P dollars. The revenue R in dollars is R of P is going to be divided by the formula -7P squared plus 21,000 P. So again, revenue is the money taken in. So by selling a dryer at a certain price, you're taking in so many dollars. So the question is, what unit price should be established for the dryer to maximize revenue? What is to maximize revenue? So again, you would think you can just set up the highest price as possible, but this is when you get into the market value. How much is a person willing to pay for a dryer? So that's what you're trying to figure out. And that's where mathematicians come into play, is they help you research the market value of a dryer. So a lot of the stuff goes into people use advertising and things to help you try to navigate to their product. So a lot going on here, but notice how it says maximize revenue. Now, also notice that this is a second degree function. So this does take on the shape of a parabola that's opening down. So we can use technology if we want to figure this out, or we can do this by hand. It doesn't look like that hard to do by hand. But when it says maximize revenue and everything in unit price here, we're kind of picking up on the vertex of a parabola. So let's change this to a different color. So the vertex of a parabola, again, if the function is in the form of f of x equals ax squared plus bx plus c is equal to 0, then I can find the vertex by using the formula x equals negative b over 2a to find the x value, and then substitute that in to find the y value. So remember, the x value in our case is going to be the p. So p is actually going to be negative b over 2a, and that's going to represent our unit price. So if we look at our function f of x, actually our function is R of P equals -7P squared plus 21,000 P. So notice how the quadratic term is the P squared. So the -7 is actually our A. Our B is actually the coefficient of the linear term, which is the P. So the B actually is the 21,000, if you can keep that all straight. And then there's not a constant here. We don't need it. So we have to take the opposite of 21,000, which is going to be negative 21,000. And then we're going to divide this by 2 times -7, which is negative 14. So the easiest way to do this is use the calculator. So negative 21,000. If we divide that by negative 14, that gives us then 15,000. Well, that doesn't sound right. Do I got too many zeros in here? Let's see here. -7. So price is negative. 15,000 sounds awful high. 1,500 would sound more reasonable. Let me think about this for a second. Let's see what's going on here on this. So what I'm seeing is I don't have negative 21,000 in here. I've got 4 zeros. So let's try that again. Negative 21, 1, 2, 3, divided by negative 14. So 1,500 sounds like a more reasonable price for a dryer. So usually these problems are real world, so kind of double check your math there. Put one extra zero in there and made it not make sense. So 1,500 is actually the price of a dryer. So if the price of the dryer is 1,500, what's going to be the maximum revenue? So that's where we'd actually be evaluating this R of 1,500. So the 1,500 would go in. That's going to be -7 times then this 1,500 squared plus 21,000 times this 1,500. And that would give us the revenue that they're anticipating by selling dryers at this price. So -7 times then this 1,500 squared plus then this 21,000, 1, 2, 3, times this 1,500. That should give us our maximum revenue. So the unit price was this 1,500. And then the maximum revenue, we have this 1,575. And then 4 zeros. Yeah. So if I come back through here with commas, so 15,750,000 would be the revenue that we'd be anticipating by selling dryers at that price. So notice how this would be kind of tricky to do with the graphing calculator, because you have to make the graph appear on the screen. And notice how the Y value has to be really, really up there a little bit. So if I do try to use the calculator on this, we have this -7 x squared plus 21,000 x. If I try to graph this, notice that I don't get much of the graph going on here because of the extreme values that we have to do. If I look at the table, it makes sense to only go in the positive direction. So what I'm trying to do is watch this go down, but notice how it's not going to go down until around 1,500. So really the only way we're going to see this graph is actually do a little bit of algebra first. So by knowing that the x value is 1,500, I could change my x window to be, 1,500. I could probably go like to 3,000, because I'm thinking in prices of dryers. If I do that, I may want to go by 500 on the scale. If I now graph it, I don't see anything. But if I go to the table now, what I could do is do a table set and maybe start at 500 and make the change in my table go by, say, 500. And if I go now and graph this thing, or in my table, I should say, notice that we're kind of seeing things a little bit more clear, but notice how these numbers get really crazy because of scientific notation and everything. So notice how that's like a 158 and then 7 more zeros, versus the 7 means you're going to have seven decimal places there. So you have to have 5 more zeros there. So that gets still very complicated to understand this using the window on the calculator. So you'd almost have to change, but if I do go ahead and change my X max to around 30 million, well, let's say 30 million. So I need 6 more zeros. 1, 2, 3, 1, 2, 3. Here, you probably need to make your scale go by a million. 1, 2, 3, 1, 2, 3. If I hit the graph now, notice how we actually start to see it materialize in the screen. So it would take a lot of manipulation to make this thing actually show up. Now, if I actually do the second calculate and go to number 4, maximum, go left bound a little bit, hit enter, right bound, hit enter, and then hit enter again. Notice it does give me this 1,500 and this 15,750,000. It does do it, but it's almost easier to do this one by hand than try to do all the calculator stuff. So notice I really messed up the settings on my calculator. So a table set, I may want to change back to, again, 0 and go back to 1s there. That's usually all we do there. We may want to change our window back to number 6 to get that all back to normal as well before we leave that problem. All righty, that concludes quadratics and their models.